February 12, 2013, explosion, nuclear. Then this is the January 6, 2016 explosion. They have similar feature, very similar structure as far as the wave.
Which means the nuclear test was not the more powerful hydrogen bomb North Korea had claimed. Seismologist Dr. Ghassan Al-Akabi is a research scientist at Washington University. Essentially, he's a seismic sleuth.
So it was the exact date. Yeah.
Analysis of seismic waveforms can distinguish the types of bombs detonated. The seismic station putting Al-Akabi's research on the map is this one in Baghdad. As principal investigator, Al-Akabi put the seismometer in himself as part of a network of 10 seismic monitoring stations in Iraq. These stations were set up in 2005 during the Iraq War, with funding from the U.S. Air Force. Al-Akabi's colleague at Washington University, Dr. Michael Wysashian, explains U.S. Air Force involvement. He says one reason behind the funding is to monitor any signs of nuclear tests in Iran. He details the history from the Cold War era when nuclear testing was moved underground, describing how the Air Force had to change its methods of monitoring.
If the nuclear tests are underground and you can't see them from your Air Force planes, what do? Well, the U.S. Air Force funded the first global network of digital seismometers.
And now?
Places that have nuclear bombs like North Korea, Iran, Pakistan, and India, if you can put in seismometers in the surrounding regions, this is something that's of great interest to the Air Force.
For Al-Akabi, who is from Iraq, his research was meaningful in other ways because he could help scientists there create a seismic record for the country. The recorded data was intended to be retrieved when needed or over time. So years later, as Al-Akabi is reviewing seismograph readings from the Baghdad station, he made a series of discoveries matching data to car bombs, helicopter flights, drones, and large explosions, including this one in 2006. 4 miles from the Baghdad seismometer, this ammunition cook-off followed a mortar attack by insurgents against U.S. forward operating base Falcon. The cook-off lasted for hours.
It was continuous for more than 36 hours. So we recorded all these explosions and with the various times and various sizes.
It was filmed by U.S. soldiers who posted the video on YouTube. Al-Akabi matched his data from the seismic station to this video and news reports, using them to exemplify the findings.
It's rare to have a situation where you have a seismometer so close to major activity, and you could see the whole sequence of events. The mortar fire that hit it, the major explosion where it first started catching on fire. So here are 3 hours that cover before, during, and after the initiation of that cook-off. Initially, things were pretty quiet, and then you see some mortar fire coming in, which heats up just before a large blast that occurs at 19 hours and 40 minutes. And that was the initial blast that caused the fires that then began to cause a cook-off of ammunitions. The energy that was released by these different signals. So here's a large explosion right here, and you can see this bright line here shows that the explosion is really centered at about 5 hertz. This is all that was left of the Air Force ammunitions depot. There are craters in the ground from some of the large explosions.
With this, the research team had a unique opportunity to test their ability identifying ammunitions, bullets, whizzing rockets, explosions, car bombs, and helicopters, all from their own unique seismic signature.
Later on, when Ghassan had looked through the seismograms and found 2 car bombs that had happened nearby, they each have a unique signature. We can even see helicopters passing by. For instance, look at what's happening in here. There's some higher frequency energy, but it gets lost among all the other noise. But if you look at the spectrogram, you can see this drop, this sort of S-shaped signature. That's one of these helicopters flying by that as it comes initially, it's at one frequency, and then as it's moving towards you, and then as it's moving away from you, you hear a different set of frequencies. Here's an example of mortar fire. This is a 2-minute seismogram, and you can show the repeated signal of mortar fire, and you can see how they all look fairly similar. They're about the same amplitude, and if you zero in on 3 of these, you can see that the shape is about the same for each one.
Advancing new applications of forensic seismology.
That is using essentially the sounds of an event, whether it's the detonation of the World Trade Towers or the Oklahoma City bombing or a mine collapse in Nevada or even the implosion of a submarine, such as what happened with the Russian Kursk submarine. You can tell the sequence of events by looking at the records in the seismograms, which essentially act as ears to the ground.
As a consultant for the U.S. Air Force, Al-Akabi studied the U.S. airstrike on the ISIS car bomb factory in Iraq in June 2015. Al-Akabi says a seismic station 55 miles away recorded the early morning blasts filled with Humvees, tanks, and explosives. The seismic record has evidence of what ISIS had inside.
So how much explosion they have, what it was, where, what the extent, how much bomb you used, how much explosion was, how it was in place. So all this important information.
In the case of Al-Akabi's research, no one monitored this seismic data as it was occurring, but real-time seismometers are becoming the real deal, using technology to transmit the actual vibrations and motions of the Earth in real time. Using triangulation, Wysashian says a seismic system has the ability to pinpoint violent attacks, preventing loss of life and property by giving first responders the best chance possible.
I envision a time in the not too distant future where all major cities have seismic arrays as part of their urban monitoring. If there is any sort of, gunfire, explosions, bombs going off in one part of a town, you'll very quickly be able to determine what it is by looking at the seismic signal and where it is by looking at the network of seismometers that can triangulate and locate where it's coming from.
Real-time seismic sleuthing is also important in a combat zone. As Al-Akabi says, seismology is turning into a battlefield technology.
Helicopters, which are not seen by radar, we could see them by the seismometers. I mean, low-flying object, we could see them by the seismometers.
So many applications for seismic sleuthing beyond earthquakes, which is why these men are on the frontier of something big. In fact, seismic.